Hello, in this video tutorial, we will be practicing Skills Practice 14.2 Parallel Circuits. Please remember to have your calculator out and remember to pause or rewind the video as needed. Let's begin. Read along with me. It says a parallel circuit has at least one point where the circuit divides, creating more than one pathway for current. Each pathway is called a branch. The current through each branch is called branch current. If current flows into a branch in a circuit, the same amount of current must flow out again. This is known as Kirchhoff's current law. Because each branch in a parallel circuit has its own pathway to the battery, the voltage across the branch must be equal to the battery's voltage. If you know the resistance and the voltage of the branch, you can calculate with Ohm's law the current. Voltage in parallel becomes the same. So here's basically what they're trying to tell us. If we take a look at this circuit here, you can see we have one bulb that has its own loop of current with the battery. But you can see how this other bulb has its own loop with the battery. So since you have this voltage, this potential, that potential, since there are no resistors here, here, and here on that side of the circuit, you can actually state that the potential all along the top of the circuit must be 12 volts, 12 volts, 12 volts, and 12 volts all the way across. The negative side of the battery, the shorter side, is 0 volts, 0 potential. So I can annotate this circuit as 0, 0, 0 all the way across the bottom. The potential difference across the battery would be 12. You can see the potential difference across each light bulb is also 12. So this is going to be a major theme that we're going to be focusing on in this practice, at least the first half of this practice, that is. And then as voltage in parallel pathways is the same amount. So with that, let's begin. Number 1, part A, what is the voltage across each bulb? Well, we established it already. It was 12 volts across each one. What is the current in each branch? Well, the current is going to be your voltage divided by resistance. So we're going to go 12 volts divided by, you can see each one is going to be a 2 ohm resistor. So we just need to show this calculation one time. And 12 volts divided by 2 ohms would be 6 amps of current. What is the total current of the battery? Well, I total would be, you have 6 amps going this way, and you have 6 amps going this way. Well, 6 amps plus 6 amps right here must add up to 12 total amps. Finally, use the current, total current, and the total voltage to calculate the total resistance. So resistance would be voltage over current. So that would be 12 volts divided by 12 amps, which would be 1 ohm of resistance. Now in question number 2, you can see not much has changed. The major difference, of course, is that each light bulb is now slightly higher resistance. How does that affect anything? What is the voltage across each bulb? Still 12 volts, as both of these are in parallel across that resistor. And again, we can see that by taking a simple first step. Draw the current through the circuit. The current would go up, over. When it gets to this point, it will split. I'll split into some gray current and blue current. You can see the gray and the blue combined to give you the total black current coming back to the battery again. So current in parallel is summed, but voltage in parallel, 12 volts, 12 volts, 12 volts, 0, 0, 0. You can see the potential difference, the difference in voltage on each side of the circuit is going to be the same all the way throughout. So we have 12 volts across each bulb. Again, the current across each branch, again, only needs to be calculated once. It's V over R. which would be 12 volts divided by 3 ohms, or this time it would be 4 amps. Okay, now the total current would be I total would be 4 amps plus 4 amps, and each branch would be a total of 8 amps from the battery. And the total current can be found by taking the total voltage, take the total voltage divided by the total current, and we will get the total resistance. So R equals V over I, which would be, in this case, 12 volts over 8 amps. Which is roughly about 1.5 ohms. Okay, now we can see we're working with nothing but parallel circuits. So we can see that the current is going to be splitting up and the voltage should be the same through each resistor. Voltage is the same in parallel. So question number 3, we're dealing with this circuit. Now the main difference is the bulbs have different resistor values. It doesn't matter. The rules for parallel circuits are exactly the same. What is the voltage across each one? Same as the battery. 12 volts, 12 volts. What is the current across each branch? Now we have to do the calculation twice. I'm going to call this resistor 1. I'm going to call this resistor 2. So current across resistor 1 would be V1 over R1, which would be 12 volts over 2 ohms, or 6 amps. The current across branch 2 would be 12 volts over 3 ohms, which would be 4 amps. That should make sense to you. The current follows the path of least resistance. We're getting more of the current in the pathway that is least resistant. The total current is still going to be summed. So I total is going to be 6 amps plus 4. Not sure why I wrote 4 ohms. Should be 4 amps rather. Plus 4 amps equals 10 total amps of current. Use the total current and the total voltage to calculate the total resistance of the circuit. So resistance would equal 12 volts divided by 10 amps, which is about 1.2 ohms. In number 4, we have a parallel circuit that has 3 resistors across it. So what is the voltage across each resistor? Well, it would be 9 volts, 9 volts, and 9 volts, same as battery. What is the current in each branch? Well, I'm going to call this resistor 1, resistor 2, and resistor 3. So I1 would be V1 over R1, so 9 volts over 2 ohms. That would be 4.5 amps. I2, current 2, the middle pathway, would be 9 volts over 3 ohms. That's going to be 3 amps. And I3 on the third pathway is going to be 9 volts over 1 ohm, or 9 amps. The total current in the circuit would be your, so I total would be 4.5 amps, 4.5 plus 3 plus 9, which is about 16.5 amps. So you can see the more resistors we put in parallel, the more the total current goes up. Now, in this exercise, we are going to practice combining resistors. Now, in class, we took some time to show you how this equation is formed. 1 over R total equals 1 over R1 plus 1 over R2. Now, this equation actually continues for however many resistors you have in parallel. But let's say you just focused on strictly 2 resistors in parallel. We showed in class how you can transform this equation here into this equation here. Okay, and so what is this equation for total resistance? Well, total resistance in parallel is the product of the two resistors divided by the sum of the two resistors. And that's ultimately what we're going to be practicing. So in this example here, you're given two 6-ohm resistors. So we went 6 times 6 is 36 over 6 plus 6, which is 12. Divide the two and we get 3 ohms. Let's try this together. Okay, so two 8-ohm resistors. We're going to go 8 times 8 over 8 plus 8. Well, 8 times 8 would be 64 over 8 plus 8, which is 16. Divide the two and we get 4 ohms. So what we're doing in this exercise is we're taking different resistors in parallel and we are combining them to get a total resistance for the circuit. Two 12-ohm resistors in parallel. Well, we would go 12 times 12 over 12 plus 12. That's 144 over 24. Divide those two and you should get 6 ohms. So how does it work when you have resistors of non-like values, different resistors? It works the same way. So we'd have a 4-ohm resistor and an 8-ohm resistor. So 4 times 8 over 4 plus 8. On the top, we have 32. On the bottom, we have 12. Now, when you divide these two, you're not going to, of course, get a whole number as you've been getting. So it's, around 2.7 ohms, 2 2/3 of an ohm. But you're going to essentially write down the decimal approximation when necessary. Now we have a 12-ohm resistor and a 3. We'll go 12 times 3 over 12 plus 3. 12 times 3 is 36. 12 plus 3 is 15. You know that 15 goes into 32 times, so 15 would go to 36 2 times with 6 left over. So this 36 divided by 15 is about a little less than 2.5. It's about 2.4 ohms. So then what happens if we have multiple resistors? In other words, more than 2. So let's say you had 3 resistors in parallel. Well, what you do is you work the formula, product over sum, with the first 2 resistors. We'll call the first 2 resistors A and B. Then you combine those resistors, okay? You use the combination of those resistors with the formula and use that with resistor C. So let's see how this works. 3 8-ohm resistors. Well, we're going to take the first 2. So we have 8 ohms, 8 ohms, and 8 ohms. Let's take the first 2. 8 times 8 over 8 plus 8 is 64 over 16, which is 4 ohms. You're going to take that and you're going to run that against the third 8-ohm resistor. So 4 times 8 over 4 plus 8 is 32 over 12, which is about 2.7 ohms. Two 6-ohm resistors and a 2-ohm resistor. We'll start with the two 6s. 6 plus 6, or 6 times 6 over 6 plus 6 is 36 over 12 is 3 ohms. Take that and we're going to run the calculation with that and the 2-ohm resistor. So 3 times 2 over 3 plus 2 would be 6 over 5. Go ahead and divide those two. And you get around 1.2 ohms. Finally, we have a 1, a 2, and a 3-ohm resistor. So 1 times 2 over 1 plus 2. 1 times 2 is 2 over 1 plus 2 is 3. That's about 0.67 ohms, 2/3 of an ohm. That is going to be your first part. 0.67 times your third resistor, 3, over 0.67 plus 3. Well, 0.67 times 3 is about 2.01. 3.67 plus 3 is 3.67. And we get a total of about 0.55 ohms.